there are two things in a wave. One is the motion of the particle and motion of the wave. So sometimes the wave travel in this direction, left and right directions, and the particle move in up and down direction. And sometimes the particle move in this directions, left and right. The wave also move in the left and right direction. So based on the motion of the particle and motion of the wave, we can divide the wave in two categories. One is the longitudinal wave and transfer wave. Sound is the example of the longitudinal wave. When it travels through the medium, the particle of the medium move forth and back and create the disturbance. And we can say the motion of the particle and the motion of the wave are in same directions. And this is called the longitudinal wave. So for example, this red represents the molecule distributions if there is no sound. When the sound travels through the medium, the molecules move this direction and this direction. Hence, they move forth and back and create some dense area and less dense area. Right? They move this directions to create the dense here, and if they move in the other direction, they create that dense area in other region. So, and this is dense area is called compression, and this is less dense area is called rarefaction. In this way, the disturbance of the wave can travel from one place to another place, and in this disturbance, the motion of the wave and the motion of the particle are in same direction, and this is called longitudinal wave. Here is the example of the longitudinal wave, and the molecule compressed here and decompressed here, and the distance between this compression to next compression is represented by a wavelength. You can see the wavelength from this compression to this compression, right, is wavelength. And the time travel from the one compression to another compression is equal to the time period. So you can calculate B equals to lambda into frequency, or lambda is frequency is like lambda by t. So we can calculate the velocity of the sound if we know the lambda and time period. Transfer wave. The transfer wave is a little bit different than the longitudinal wave. In the transfer wave, the motion of the particle and the motion of the wave are in perpendicular directions. The particle oscillates in up and down directions, and the wave travel in the forward and the backward directions. One of the perfect example of the transfer wave is water wave, in which the water molecule oscillate up and down like this, and but wave travel in the other direction. So water molecule like this direction is the motion of the particle, and the wave travel like this direction. This is a disturbance travel in this direction and wave direction, and they are perpendicular each other, right? And this is called transverse wave. All the electromagnetic waves are transfer wave, in which electric and magnetic field oscillate in the perpendicular direction to the direction of the wave. So the electric and magnetic field oscillate like this or like this, up and down or this direction, right? But wave travel in other direction, this direction. So, and this is the wave directions, this is the particle direction. And we will study more about the electromagnetic wave in next few sections.
Here is the example of the uh, transfer wave and longitudinal wave using the slinky coil. If you move the slinky coil up and down directions, the disturbance travel in the perpendicular direction. It is called transfer wave. On the other hand, if the particle moves along the direction of the slinky coil and the disturbance also travel in the same directions, and it creates the longitudinal wave.